We have a graph, so we will analyze it first for what information we can glean. The origin is not 0, 0. The vertical is 0, but this is 0.0010, 0.0020, so 0.0000 would be all the way over here at the edge of the paper. So if we're looking at the coordinate plane that we're looking at a graph that is situated over here. That's a good thing for us to know. The y-axis is force in normal units. X-axis is time in normal units, so therefore any questions about force or time we can simply read off the graph. The slope, again, is delta F over delta T, which is the rate of change in force. And the area is F delta T, which is the impulse by definition. And that impulse is equal to the change in momentum, which is m delta V. If we want the area of this graph, that area of the graph would give us the change in momentum. And that change in momentum could also be arrived at by using the average force times the change in time. So this blue area is equal to the area of the rectangle given by F bar, the average force, over the time it's applied. So we have a 2 kilogram now going on to the question. We have a mass of 2 kilogram colliding with a 1 kilogram that's at rest. So we have some velocity. We have a V0 equal to 0 here. We have the force time. And, of course, we know that the force that the 1 exerts on the 2 is equal and opposite to the force that 2 exerts on 1. So F21 is equal and opposite to F12. They're equal and opposite to each other. Afterward, the 2 kilogram object has a speed of 2 meters per second. And so we have to be careful there, because all we know is its speed. The speed of the 2 kilogram could be in this direction or in this direction. It could be plus 2 meters per second or minus 2 meters per second. And the 1 kilogram object has a speed of 8 meters per second. Now, the speed could be positive 8 meters per second or negative 8 meters per second. That's just from the description. We need to determine, the student is asked to determine, the initial speed of the 2 kilogram object. Now we see the force is positive. So that means the area is positive. So delta P is positive. And that delta P is going to be equal to the area, which is 4,000 times the change in time, which is not so easy to determine here. This looks like about 0.00125, and this looks like 0.0024 perhaps. Looks like that's the change in time. Shows the correct substitution into delta P so that the initial speed of the object can be determined. So let's see what we're given for choices here. So here we can see there is a force and a change in time. Here we have a mass, and this is a delta V. So there's a substitution, and this F is F max. This is using the maximum force, which is this, being multiplied by a total time of about 0.00125. So we definitely would not be using the maximum force for this. So this choice has to be out. The next choice, we have a mass, and it looks like we have a delta V. And now we have an average force, delta T, because the average force exerted on the 2 kilogram object must be considered. And that is true. Looks like that's our answer. 2 kilogram minus 1 kilogram is delta M, and this is delta V. And this again uses F max. So we're never going to use F max for this. And here we have a delta M again, delta V, and the average over the period of time. So looking at these two equations, we don't take the change in mass. We are looking at the initial speed of the unknown object can be considered. So the best answer is this choice.